All right, let's learn some terms here. Okay, first of all, we all know what multiply means, right? So everything on the worksheet, everything on this lesson, we will be multiplying. The next word is rational. Can be written as a fraction. That's what rational means. There's some numbers that aren't rational, like the square root of 2. That's not a rational number. You cannot write it as a fraction, like say 17 over 10 would be 14 over 10 would be the closest fraction to it, which would reduce to 7/5. But that wouldn't be quite square root of 2, so it can't be written as a fraction. Everything on here is going to have a fraction. Algebraic. It's kind of hard to explain that word, but just to simplify it, we'll just say it contains variables. So you're going to see fractions on here, you're going to see multiplication, you're going to see variables. And the word expression just means like something that's not an equation in math is the easiest way to explain what an expression is. So like if you had 3x squared equals 27, say, 3x squared would be an expression, 27 would be an expression. It's kind of like a term, except you can add a bunch of terms and that would make one single expression. So it's just definitions, that's all. Any questions on that? Okay. So what is a rational algebraic expression? Well, the key is, at least for the sake of this lesson, there should be a variable in the denominator, usually, okay? Especially when you get into pre-calc and you start graphing rational functions. They take on special properties when there's a variable in the denominator. When there is no variable in the denominator, it acts more like a polynomial, okay? So technically, in order for it to be a rational algebraic expression, there's going to be an x in the bottom. It won't really matter for the sake of how you solve the problem, but it matters more when you start to graph them, okay? So the reason why this one we don't have a check mark next to because it's just 11 in the bottom. All right, let's go ahead and take a look at the first example. And I'm going to kind of quiz you guys a little bit. A large part of this lesson is going to be factoring, which we've done a lot of. And that's actually the first step, is to factor each individual expression. Now, normally you're going to have 4 expressions, okay? You have the top of your first fraction, that's an expression. The bottom of your first fraction. The top of your second fraction. The bottom of your second fraction, the denominator. That's 4 expressions, right? 4 components, whatever you want to say. So let's go through each of these and figure out which method you would use to factor. Starting with 4x squared minus 9. Difference of squares, yes. That's because the first term you can take the square root and get something back. The second term you can take the square root and get a whole number back. The bottom, kind of a trick question. It's already, you can't do anything. Can't pull out a GCF and we're going to leave this one. All right, how about this one? It has 3 terms. X method, very good. And right here, pull out an X. That's right, pull out a GCF. So we have 3 different factoring methods in this problem. Difference of squares, X method, and pulling out a GCF. So that's what you're going to see on the next page. Oh, I skipped a page, didn't I? There we go. This is just the same thing with the different methods labeled out. That's all that is. Okay, however, we can go ahead and start the X method for the top right. It's kind of, well, actually, let's start with just the simplest one. The GCF of the bottom right would be would be X. Why did I put a 2 there? That should say X. Let me fix that. Okay, on the bottom right, when you pull an X out, you're left with 2x minus 3. So that's all you can do on the bottom right. That's the simplest version of factoring. We're going to leave this one like we said. Let's go ahead and do the X method on that one, then we'll do the difference of squares for that one. So X method for the top right, 10 times 12 on the top of the X, 120. 23 on the bottom. 15 times 8 gives you 120. 15 plus 8 gives you 23. So it breaks down like that. You pull out a 5x for the first 2 terms and a 4 for the second 2, and it finally becomes 2x plus 3 times 5x plus 4. So on the next slide, you'll see this will be replaced by that, the factored version. This will be replaced by the x times 2x minus 3. We're going to leave this one. Final question I have for you guys is the 4x squared minus 9. I'm going to do that somewhere down below here. I'm just going to rewrite that. Who remembers how to factor this using the different squares? First of all, let's just figure out our a term. A would be the square root of that. What's 2x? Thank you, yes. The square root of the second one would be 3. And then you just do what? You do 2x plus 3, a plus b, and then a minus b, 2x minus 3. So we're taking all of that information and we're replacing everything on here by its factored form.
Can you just like...
Stay there? Or do you have a question?
Can you just write 2x plus minus 3?
Yes, you can. So it becomes this. Top left, difference of squares, 2x minus 3, 2x plus 3. Order that you put it doesn't matter. Bottom left stays the same. Top right, we use the x method. Bottom right, we used GCF. So that's our first step, which is like the step that takes the most work, right? Because we just did 3 different methods of factoring, namely, completely factor everything. So like I said, you'll have 4 components. Sometimes you have to just leave one of them the way it is. Okay, so can you guys see what you would do next to simplify this? Cross cancel. Yes. Namely, the 2x minus 3 is up here, right? On the top. 2x minus 3 down here on the bottom. We can cross cancel that. Now, we have a 2x plus 3 on the top, but there isn't one on the bottom, it's just on the top. You can't cross cancel if they're on the same side of the fraction. So that won't cancel. What about the 5x plus 4? Yes, it will cancel with that one. So your next step is to cross cancel that stuff, and on the top you'll be left with 2x plus 3 times 2x plus 3. On the bottom you'll be left with x. So step 2, cancel common factors in the numerators and the denominators. Okay, your next step is going to be multiply / simplify whatever you end up with. So can anybody tell me, how would you simplify 2x plus 3 times 2x plus 3? I'll give you a hint. We will not FOIL it. What's another way of saying that? What's another way of saying something times itself? Squared. So we're just going to write 2x plus 3 parentheses squared. Okay? So again, you could call step 3 simplifying, because that's actually what you're doing. Simplifying the numerator. Because when you multiply those things, you don't want to FOIL it, because then you'll end up with 3 terms. It's better just to have one term like this squared. It's just simpler. The bottom is going to be step 4, multiplying the bottom, but there is nothing to do, right? So that's going to be your answer. Those are the 4 steps. Step 1, factor. Step 1, factor. Step 2, cancel. Step 3, simplify the top or multiply the top. Step 4, simplify the bottom or multiply the bottom. And so you can see that, what were the directions to this question, actually? Does anybody remember? Simplify, right? Your answer should be a lot shorter and a lot simpler than what you started with. So we started with something with all those terms, and we ended up, I'm having a hard time finding this. We ended up with that, which is much simpler. Okay? All right, let's move on to the next example.